Israeli, a Japanese, and a German walk into a Silicon Valley conference room. Sounds like the beginning of a cheesy joke, right? But it's actually a beginning of a great opportunity for us. An opportunity made possible largely thanks to LinkedIn, guys. So let's start with the applause. My name is Shlomi Ben Chaim. I'm the CEO of JFrog, and we are very happy to see you all here and excited. I think it's safe to say that continuous integration had launched a quantum leap, so to say, into a new world. Things will never be the same in our environment, and we are very, very excited to be part of what's going on in the environment. This conference, sorry. This conference would not be possible without the great cooperation of several parties. So first and foremost, I'd like to thank LinkedIn and Ivo Michov for making this event a reality. And really, people, he worked hard for it. So thank you, Ivo. I'd also like to thank Hans Doctor and Ken Sipe of Gradleware, which are our close friends and partner, and especially for providing us with such a great tool as an alternative for BuildTool. Thanks, guys, for being here. Of course, Kosuke Kawaguchi, I think that I'm saying it right, of CloudBees, who continues to bravely lead the Hudson community through the Jenkins project, right? Thanks for coming. So today you will have the opportunity to see them all in action together with JFrog CTO, Yoav Landman, on one stage, and they will discuss the hottest issues and solutions in CI today. So we hope you enjoy this day. And we would like to thank everyone in this room for coming and everyone out there viewing us online for being there virtually. So without further ado, I would like to introduce Ivo Michov of LinkedIn. Thank you, guys. Enjoy the evening.
Thank you, Shlomi. Hi, everybody. Thank you for coming. We're very excited to host this event, and we thought about opening tonight with a little showcase of how we're solving some of the problems in the area of continuous integration, build and release, and share with you some of the technologies and the tools that we're employing in our tool chain and sort of the direction that we're currently going as it pertains to the rest of the presentations tonight. So we're gonna cover what we're currently using, which is a homegrown framework that's evolved over time based on Ant, later on integration with Ivy. We're going to look at what we're currently exploring and the direction that we're taking with Gradle and the continuous integration system that we're using. Jenkins, for our binary repository, we're using Artifactory, and we're going to wrap up with a glimpse of our deployment platform called Glue. So just to give you a sense of the magnitude of the problem that we have, these are some metrics that I pulled the last couple of days of how our source tree has grown over the last 5 years. I've been here for a little over 6 years, and I have been working in the area of build and release for all of that time until very recently. And I have to say that looking at the numbers over the last 5 years, we're currently at a little over 3,000 build files, and we're building a little over 26,000 Java files, and we have a monolithic source tree. Helping me tonight in this presentation are some of my fellow coworkers, Ricardo Ferretti, Manish Dubey, and former employee and founding member of LinkedIn, Jan Pujante. I would like to introduce Ricardo, who's going to cover the first part, our build.
Hi guys. So what we want to do here is to kind of like give you an overview of the evolution of our build framework throughout these years. So what Ivo was showing at the beginning was the number of modules and build files that we had back in 2006 and how this has grown over time. So to kind of, what I'm going to talk about is the build framework that is largely, mainly used today at LinkedIn. We are moving to a new framework that is based on Gradle, and we'll briefly talk about it at the end of the presentation, and kind of like show the evolution, how certain things have evolved in a certain way. So first of all, end-based build framework, just a collection of custom macros and tasks and shared targets. We introduced some conventions around the source tree to make it easy for people to add new modules. Again, centralization of the logic. One of the main requirements for this build was to be able to support dependencies across the different modules. And by putting all the information in a central location, the build files were left mostly for declaring dependencies across modules and perform custom actions that were needed. And we'll see how also once we started introducing Ivy, this declaration was brought to like a different level. So this is what the build file looks like. It's kind of small, but I'll try to kind of go through the main areas. And this is like back in 2006. We were importing the main targets from a few central files that were in the framework. The source code of the framework itself was actually together with the source code, with the code base, which we will see later is actually quite a problem. Moving on to the dependencies, we were encapsulating all the information that was dependency related in a target called dependencies. So the idea here was to simulate a dependency section of a POM file in an end style. So this is still a target. These are actually actions. So we're not really declaring. We're more like organizing the build file in a way that it looks like we're declaring. We're organizing in a way that's easy to find the dependencies. But still, it's all very declarative. It's all very imperative. The other thing I want to mention is how the build would allow you to easily extend the default behavior in case you needed to perform custom actions. So next is one of the major refactoring that we did with the dependencies declaration. So here you can see that actually the dependencies, this is still a build file. This is a valid build.xml file. What we did is we introduced Ivy. We built a custom parser for Ivy. Ivy totally supports that. There was nothing weird about it. It's totally supported by Ivy. Ivy is very flexible in that regard. And then we added a dependencies section in our build file where you can actually define dependencies either on internal jars, on internal modules, or on external jars. One thing that I didn't mention about the previous file is that the way we were defining dependencies on external jars was just by having a file set. And that, of course, has a lot of consequences. There is no conflict resolution. There is no transitive dependencies. And it's also a non-uniform way of declaring dependencies. These are your external dependencies. These are your internal ones. Whereas here, we consolidated into one syntax for everything. So the migration to Ivy allows us to do a few things. So first of all, if you see here, we used to have a very simple flat layout for the dependencies. So we actually moved to a model, but we used Ivy resolvers to basically migrate our flat layout into a Maven 2 style. The migration was actually incremental. We started by reorganizing our code that was checked into the source code into a directory layout that was actually mimicking the Maven layout. This allowed us to start introducing these dependencies. It still had the benefit and the cost that the jar files were in the source code. But it made it easy to go to the next step, which was the extraction of this repository into a standalone machine that we were able to access using HTTP. So, and given the ability of Ivy to just define quickly a new resolver and put it in the chain, it was easy to actually achieve this goal. The other thing that I think it's interesting to note is this legacy dependency. So basically that defines a dependency on an internal module. Basically our framework was analyzing this section of the build file and figuring out that when it sees a legacy dependency, do not go through Ivy, but instead build the module from source and then add it to the class path. Before I get there, the other thing I wanted to mention is, so this incremental extraction of build files, so of libraries. So first, we moved them into a local directory, Maven layout. We put it onto an external repo. We started to experience some problems there, mostly due to managing the increasing numbers of jars, which kind of like brought us into initiating a conversation with Artifactory, which is what JFrog and Artifactory, which is what we use now. And it's worked out pretty well for us. It still allows, mostly like things like class searches or finding certain dependencies is actually working out really well today. So kind of like looking high level at the framework during these years, and in preparation of the next iteration, one thing that my boss asked me before moving on to the next framework is like, I want you to write a wiki page where you tell me exactly everything that was wrong with the previous framework, because I want to make sure that you're not going to make the same mistakes again. It's like, fair. So we did that. So one thing that we noticed, well, we noticed well before, but definitely was a big problem. Having the build framework inside the code base was having problems. When we were rolling out a new change, it actually had to follow the release and branching scheme of the rest of the code, which sometimes caused timing issues with the rest of the frameworks. Another thing is that for convenience reasons, we decided to put everything into this build framework. From there, you could build a jar, build a war, deploy a war, provision a container, create the configuration files for the environment, drive the test execution. So all these different, manage the DB, we need to load data in the DB. All of this was very convenient, but it came to the cost that we didn't spend enough time to define the proper APIs between the different components, and one change in the build side could have had consequences on the rest of the tool chain. And you know, long end files. End is not the best language for scripting. Let's put it that way. So what are the lessons learned? So we did this in the first iteration, definitely. Encapsulate the logic in the framework. Have the build file be as declarative as possible. You want to provide extension points because you want to allow the developer to have the freedom to tweak the behavior if needed, but mostly the build should just say, this is what I need, and the framework should be able to understand what it is and act upon it. Convention over configuration, but without being too strict on the convention. Still allow additional behavior if needed, or changes in the convention if needed. Again, build framework outside of the code base. That is one important point that personally I took away. And going back to the Swiss Army knife, kind of like, it's good to provide this convenience to developers, but that doesn't mean that so think of the framework as all its different components, how they play together, and if you want to provide to the developer some entry points that allow some orchestration to make it easy for them to execute repetitive tasks easier, that's fine, but let's make sure that you keep the proper separations between the different components. And finally, use the right tool for the right job. I think that, as I was saying, we put a lot of things into this End framework. We were doing things that are probably not best suited for End. And you know, again, use the right tool for the right job. Use End for what End is good at. Use Gradle for what Gradle is good at. Use other things for whatever you need in that particular instance. So this takes us to our new build framework. What are the main differences? So first of all, it's not End-based, it's Gradle-based. This is convenient for several reasons. First of all, coming from an End world, especially End plus Ivy world, I feel like most of the work was already there for an easy migration. Also from Gradle, it's very easy to delegate to End in case you need to do that. Even though we purposely tried to not fall into that behavior. We wanted to cut the line between the old framework and the new framework. Sometimes when you try to be, of course you want to be somewhat compatible with the past, but also need to define, you need to sometimes break in order to innovate. What I was talking about, the difference between the declaration and the execution, Gradle embraces that fully. The DSL allows you to declare what you want in your build, and the plugins allows you to put that declaration into an execution that is gonna comply with what you want. Custom plugins, so it already comes with a bunch of plugins that are actually very useful. We created like a thin layer on top of the plugins that are already there. And we found that actually to be very, very helpful for us. It provides a level of abstraction. It provides us to add features when we need to. And then Groovy, much easier to script in Groovy than to script in Ant. Going back to the multi-project builds, this was a top-level requirement for us. We were used to have source-level dependencies. We think they're good, they're necessary. Gradle comes with great support for that, so we decided that was definitely to its favor. And so we leave build Gradle files to be just very declarative. You declare the dependencies, you apply the plugin that you need, and usually that's all that you are concerned about. But it's interesting, we rolled this out just in maybe a few weeks, and there are already custom behaviors, people that have code generation and want some test execution to be reported in a certain way, and we've been able without any problem to actually provide those features to them. So far the experience has actually been really good. So where is this gonna take us? So today up to recently we had a very monolithic code base, one source tree where everything was in. Now we're gonna move to a different model where we're gonna create multiple source trees. We're gonna organize the code in that way. We're gonna move to a binary dependency model where even though each source tree is a multi-project build, you will have source level dependencies within that context. When you depend on other projects, what we decided to do is to define a very clear API level layer between the different projects that you can depend upon. And yeah, so what's gonna happen next? Well, once you commit, the CI job is gonna kick in. It's gonna make sure that your test is not breaking anything. It's gonna produce a new version of the artifact. On the other side, we're gonna use versions, so the new versions automatically picked. So this is kind of on the build side. It's kind of a quick overview of what we've done in these years and how the thinking has evolved through time. Interesting to see that when we were talking to other companies, we kind of saw that there is this sort of convergence towards this model. So with that, I think at this point, I want to pass it to Jan, who's going to talk about the deployment side of things. So I kind of give an overview on the build integration, and then the last step is the deployment, and he's going to talk about Glue.
All right. Good evening, everybody. My name is Jan, and I'm going to be talking about Glue. I guess I pushed the wrong button. Yeah, because it was. There you go. So as Ricardo was mentioning, so far, we've been building the bits. So we have the build framework, and now there is the continuous integration that produces those artifacts that are put into Artifactory into a binary repo. So the next step is you actually want to take those bits and push them to various machines to have your code up and running. So this is what Glue is trying to solve, basically. So before Glue, the way that LinkedIn was doing deployment was very manual. It was done through shell scripts and people just typing commands into shell terminals and whatever. And it wasn't really scalable, and it was extremely error-prone because you can just do a typo and then prod is down for hours or whatever. And so we decided to work on this project codenamed Glue, and so we conceived it internally, and it was released. We went live last year in March of 2010, I think. We started deploying it in production, And in November 2010, it actually was released open source. So if you're interested in looking at the project, you have the URL. It's on GitHub under the LinkedIn organization, codenamed Glue. And you can find the actual open source of the project. So the key goals that we were looking for Glue was to kind of remove, the manual thing and to automate everything. And so the idea was to be able to deploy to a small set or a large set of machines, because we have small set in integration lab, but we have large set in production. And we wanted to do that in an automated fashion, in an efficient manner, and also we had some security concerns in mind, so that it was trusted, like the machines receiving the commands needed to trust where they were coming from. We also wanted to make sure that once you've deployed your bits to the machines, then if things go down or whatever, we could detect the failures, recover from them, and also making sure that as time goes by, your machine stays in sync and you haven't forgotten to deploy an application on one machine or the new version there. So that was kind of the key goals that we were trying to achieve there. So I'm really going to glimpse over the concept because it's, it would take a full presentation on its own. But one thing that Ricardo mentioned is when you look at the build framework, we really went from a model where it was very imperative, and we went into a model where it was very declarative. And that's exactly what we did with Glue. With Glue, you were issuing commands, so it was very an imperative way of deploying. The new model is actually a declarative model. So in Glue, you have a document. It's actually a JSON document. And what you can see on the screen, I don't know if it's very readable, but what you can see here is an actual snippet from one of LinkedIn's model. And this one is a production snippet. And so it's a document. So it's a file. You can check it in. Actually, we do check it in. So it's a version file. And in this file, you basically model your entire system. You declare what's in your system. So what you put in this file is you specify what you want to deploy. So in this case, we're deploying a container which has a skeleton, a configuration, and a port. So a container in this example is a Jetty container that's going to run a web application. And your web application is defined here. And it has a WAR file, it has a context path, and it also has a configuration. So the thing that I wanted to point out is, as you can see, the value for those keys are actually IV coordinates. They are not, directly coordinated to an HTTP server or whatever. They're actually IV coordinate, and so they actually have a version. Everything is version. So the container itself has a version, the configuration of the container has a version, the WAR file has a version, and the configuration of the WAR file also has a version. Everything is version, and everything is deployed in the binary repository. So the other thing that you express in this model is where do you want to deploy it? And so here you have the entries, those two entries. The agent is actually a host on which you're going to deploy your application. And the man point is just a unique key. I'm just not going to cover that because that's irrelevant here. And you also express how you want to deploy it. And so in Glue's term, the how is actually a script. We call that a script. It's actually called a Glue script. And it's a Java class that has the instructions on what does that mean to deploy a web app. And so what does that mean? It means I need to fetch the container. I need to enter the container. I need to fetch the WAR file. I need to copy the WAR file in the web app directory. So you tell Glue basically what it means to deploy a web app. And the other thing I wanted to point out is that this IV URL here is actually a last section after the version. So we're also using configuration. We're using IV configuration to specify different artifacts in the binary repo. So this is the kind of the overall architecture, what Glue looks like and the way it works. So down here you have the set of hosts. So in Glueland, you have an active agent that you install on each host. And so that agent is going to be up and running all the time. And here we also use Zookeeper under the cover. So I don't know if you guys are familiar with Zookeeper, but it allows you, it looks like a file system, but it's distributed, and it allows you to maintain state into one location. And so we use it so that every agent is actually reporting its state to Zookeeper. And so that state is being fed into the heart of Glue, which is the orchestration engine. So on the next slide, what I'm showing is the model that I was talking about, that JSON document, gets injected into the orchestration engine. And so, so in that step, you're just giving it to Glue. And so in the next step, what Glue is going to do is actually going to compare the model that you've declared in that file. And it's going to compare it to the state that's coming from the agent that are installed on each server. So it's going to compare the two. It's going to compute what we call a diff or a delta. And from there, it's actually going to be able to generate what we call a deployment plan, which is essentially a set of instructions that needs to be executed on each of those machines to basically deploy your application. And so the deployer in the orchestration engine allows you to deploy things serially or in parallel if you want to, which makes it very efficient, because if you have 200 nodes, you can deploy in parallel 200 nodes if you want to. In the next step, what I wanted to show is that little script that I was talking about that's going to say, well, I need to install the container, I need to install the WAR file, is actually going to use those IV coordinates and to go and fetch it from a binary repo, which in this case is Artifactory. And it's going to go install the software. And once the software is installed, then the state is actually changing and is being reported back to Zookeeper. And so in the next step, then the state being reported to the orchestration engine is actually matching the state that you've expressed in your static model. And so as a result, Glue is happy, everything is green, there is nothing to do, nothing to deploy. But if something changes, like for example, if a machine goes down, the state will change and immediately you'll be alerted because there is a console that shows you what goes wrong. Let me just step back a little bit to that slide. When I was talking about the fact that Glue computes a delta and execute the deployment plan, something I forgot to mention is it's not automatic. And there is a good reason for that, is we don't really want, at least LinkedIn does not really want magic to happen. What Glue does, it computes a deployment plan and actually shows you the deployment plan. And a human being currently has to say, yes, go ahead, that's really what I want you to do. Because otherwise, if it was just happening, it could just shut down prod or whatever. And so right now we have this level of security that nothing happens automatically. Although you can build a behavior like that on top of it, but right now it's not automatic. And I think that's pretty much it for this glimpse of Glue. That's kind of hard to say. During the break, Manish, who is sitting over there, and myself will be available. We can show you a demo because we have the console on our laptop, or Manish can actually show you the integration lab directly here at LinkedIn. So we can do a demo and show you the console and how it works if you're interested. Thank you.
Thank you, Jan. I hope that this was useful. Again, I want to emphasize that when we set forth into solving a lot of the problems that we have faced over the years, it was hard for us to find an organization that would share with us how they have done the same. So we believe that it's important to be as open as collaborative as possible. So during the break, please come find us if you have any questions. We have other members of the tools team here at LinkedIn. We're happy to talk to you about what we're doing, how we're doing it, and even opportunities for employment. Before I introduce the next speaker, I would like to talk a little bit about the schedule. We're going to have a break after the next presentation. We're going to get some pizza. We're going to get a chance to socialize. Again, looking forward to you guys coming up, asking questions. We're going to then continue with 2 more presentations. We're going to cover Gradle. Hans Doctor is going to talk about Gradle, and Kosuke is going to talk about Jenkins. And then we're going to wrap up with a Q&A panel. Again, a chance for folks to ask questions and for our online viewers to hear the answers. So without further ado, I would like to invite Yoav Landman from JFrog.
Is it on? Okay, so who moved my module? So just before we begin, just a little bit about myself. So my name is Yoav, I'm the CTO of JFrog. And I'm also the original creator of the Artifactory project back at the open source Artifactory project back at 2006. And my experience runs around 10 years ago around build systems, setting up development environments, and so on. So there are actually two sections, two main areas that I want to talk about today. One of them is the binary repository manager. Why do we need this at all? So I think the LinkedIn talk probably gave a nice segue for that, but I will give some more examples. And then I want to talk about using modules for continuous integration, cover common release strategies and models, and actually talk about common release issues and show how we can solve them and what the common problems are that we see with clients. So basically, a binary repository manager or a binary repository is a shared place to host your binaries, naturally. So it can be third-party binaries, it can be your own produced binaries, and it's much more than just a passive storage place. We will see a few examples later on. And it's a really critical piece of the continuous integration process. So that's quite a common question that we get asked sometimes. People are asking, okay, fine, but I'm using my Subversion repository. I'm using just a shared file system, which is very common in the .NET world, by the way. Or I'm using my Apache with my file system exposed by Apache, and whatever else. And yeah, another common thing that we hear is with keeping sources, I can build everything from source, which is, of course, a very misleading thought, because just imagine that somebody would tell you, okay, all those open source projects that you use as dependencies, they're all available out there, just pull them, rebuild them from scratch. So it's very time consuming, and it's the same for your own hosted projects. And also, there is a lot of dynamicity in what you build, so you may not end up with the same result of your build, of course. So just to iterate on that, just ask yourself, can your shared file system or version control download and cache remote artifacts, act as a proxy, promote release artifacts, control the licenses that are used by your software, track and preserve the artifacts that are actually used by CI builds, enforce security, track and all the changes, have audit trail to all the changes that you made to artifacts, automatically clean up all the integration garbage. So when you run integration builds, you collect a lot of garbage that you bless a build, but all the rest that you've built, you don't care about this, you want to throw it away. Search for artifacts, not really possible with Subversion, and use REST API to do all kind of cool management things on your repository. So if I want to look at the ecosystem, just get a 10,000 miles view over this big ecosystem. So we have the module artifact repository that is used for the libraries, and we have the version control, which is used by for storing the sources. And we have all those build tools. that basically check out source from the version control and produce modules. And of course, they also consume modules that typically come all from modules of your own that you deployed, or third-party modules from remote repositories that may be yours and maybe from the internet, basically. And in the last couple of years, we have new consumers and new producers, which are the build servers, which act like a very concurrent developer that keeps producing and consuming modules, basically littering your repository in a very, very fast way. And of course, there are all those features. So I'm not going to reiterate on them. But all those smart features on top of just storage, which you can see that Artifactory as a tool provides. So Artifactory basically is a smart repository manager that provides all those features on top of just storage and retrieval. So that's what I want to show you. So you can think about Artifactory as a platter. Everyone puts, sorry? Yeah. I'm not sure if it's that good, but Artifactory is like a platter. So let's take this Jenkins job number 1. It creates those 2 artifacts in there. Then another job comes in, maybe from another machine, grabs those artifacts as dependencies and produces its own artifacts, and so on. So a third job, again and again. So this platter is like a shared place for consuming and producing artifacts and sharing them between different jobs or between different developers. And part of the role of being this platter, so you need to integrate with all those tools that are out there in the ecosystem. So Artifactory basically provides integration, and I will make it more concrete as I go to the demos. It provides integration with all the leading build tools of today, so it's Gradle, Maven, and Ivy, with Ant, of course, and with all the leading build servers, which are Jenkins, TeamCity, and Bamboo. And I will make it more clear now what the integration is. So let's go to the first demo. So you can all see how messy my desktop is. OK, so that's Artifactory. And just if you never saw it before, it looks like a file system. So you have local repositories here, and proxy or remote repositories here. You can search and do all kind of stuff, and you get a lot of information about the things that are hosted inside the repository. You can even drill down inside jobs, which is not very interesting in this case. OK, so I'm going back now. I'm going to the UI of Jenkins now, and I'm going to demonstrate what the integration means. So this is our plugin for Jenkins, and we have the same for TeamCity and Bamboo. I'm not going to show you how you configure the Artifactory server, but you have, like you configure any other tool in Jenkins, you have to configure first your Artifactory server or multiple servers. And then I will go into a Gradle job here, and I'm going to show you the configuration once it's loaded. Yeah. So this is the Artifactory section of the configuration. I think it's more readable now. And you can do a couple of things. First, you select your Artifactory server. Now it's going to actually contact by REST API the server that's running here on my laptop. And it's going to autocomplete and give me the solution for the completion for the resolution repositories. So these are the repositories I can resolve from. And these are the repositories I will be publishing to, or just one of them, actually. And there is this little checkbox here that's called Capture and Publish Build Info, which does a lot of magic behind the scenes. So this type of integration, we have it for Gradle, and it was very easy to do with Gradle, because Gradle kind of lends itself to be extended, with Ivy builds and with Maven. So I'm not going to waste time running this build, although it's a very quick one. So I'm just going to go to the console output, and I'm going to show you what the output of this Gradle build looks like. So at the end of the build, it deploys everything to the repository that I defined. And this is really important for all the build frameworks, because that's not the natural behavior. If you remember, that's a multi-module build. And the behavior for a multi-module build is to deploy at the end of each module. So if you have module 1, 2, 3, and module 3 has a compilation issue, you would end up with partial deployment in the repository. So our plugin basically waits for a full successful build. It remembers what it needs to deploy, and it deploys everything in one go. The other thing is this little line here, deploying build info. And this is where a lot of magic happens. So I'm going to go directly to Artifactory from here. Okay. So if I want to see more of that, I need to log in. Okay. And I'm going to go back. Okay. Okay, so I get what we actually do is we intercept the build, and we capture the information about the build as the build happens. So we capture the real information about the build. And let me show you the couple of things that we capture. So we capture basic information about the build, what type of build, what version of Jenkins was running it. So Koski, I don't know if you know, but you still identify yourself as Hudson here. The version of Gradle that was actually running, how long it took, and so on. I'm going to go to another build, which is a bit richer, just to show you, first of all, before I go to this build, everything is just a big JSON object. So we actually talk with the REST API of Artifactory. We send all this information via JSON, and it's available for consumption via REST, if you wish. So it's not closed or anything like that. So let me go to another build here. So we capture a lot of environment variables from the build. So basically, you can know what JVM was used to build it, what operating system and architecture was building it. So it's like a bill of material for this build. And it's the real point of truth about what really happened here. We have all the published modules, so we can drill down to one of them. So these are the actual published modules, grouped by configurations. So these are compile time, but we also have the provided one or runtime one. And of course, I can go to the tree, and in the builds tab, I can see that it was produced by this build. So per artifact, I can know the relation to the builds. And the same goes for dependencies. So if I will pick a dependency and go to the build here, so it knows that it was used as a dependency in all those builds. And actually, if I try to remove it from the UI, it will tell me that this was used by a build, and I may be breaking the reproducibility. So that's just a UI feature, but if somebody wants to delete it from the UI, it's there. Okay. So next thing I want to talk about is release. So usually you have a release pipeline, which is just a process with various checkpoints. So normally these are different builds which trigger each other, and the produce modules, and a build goes to the next step whenever the checkpoint or the gateway is passed, and this gateway is usually testing. Okay. And this pipeline can be linear, or it can be non-linear, take a fork join form. And it really varies so much. So every time we go to customers, even here, today, it's always surprising to see the creativeness of people in creating this pipeline. But still, there are a couple of really common problems with this release pipeline and with the release process. So I'm going to cover only 3 typical ones. So the first one is picking your release strategy. The other one is keeping your release or integration process isolated. and finally avoiding license creep. So with regards to source release strategies, I'm going to cover three main strategies. First of all is release to branch, so using a release branch. The other one is the M2 release plugin. So it's Maven specific, but still I want to look at it with you. And finally, I'm going to show you what the Artifactory plugin does with releases. So merge to branch, it's quite simple. So you have the main trunk that you developed on, and there is a build that intercepts it polls the trunk, and it builds. At some point, somebody decides that the build is good, and merges it to a release. Merges all the changes from the trunk to a release branch. And another job that builds the release branch is running and creates the release. And it needs to be tagged by a developer. So it's a very simple process, very manual. So it's a little bit error-prone, but very, very simple and straightforward process. And of course, it can take a couple of variations, but that's the general principle. OK, so the other one is a very popular plugin, which is called the M2 release plugin, and it's predominantly or only used by Maven builds. So I'm talking about this because I want to show an approach, and I want to show a kind of problematic approach, actually. So these are the steps that this plugin does. So first of all, it checks out the latest version control system, and it's used quite a lot. Before I go on, how many are using Maven here for building? OK, so quite a few. And how many are using this plugin? Oh, so you're good guys. Only one. No, so kidding. OK. So we have a lot of, we saw a lot of people using it, so don't feel bad. OK, so it compiles and tests everything. It changes the POMs to the next release version. It compiles and tests again. And then it commits the new POMs, which is really, really dangerous, because if a poor developer happens to check out from the source control at this point, he will actually check the release. And he may change the release by doing that. So there is a point where you're exposed to this problem. It creates a tag from your version control. It changes the POM to the next development version. It increases the snapshot count. It commits the new POMs. It checks out the previously created tag. And finally, it compiles and tests again, just for the fun of it. And finally, it publishes to the binary repository. So it's slow. And other problems with this approach is that it's actually running Maven underneath. So it's using a client solution to drive a server-side CI solution. So you cannot really, first of all, it completely ignores your Jenkins settings and version control settings in Jenkins. And it's really hard to roll back, because it's not your own file system. And you may not have the permissions to wipe out the tag on your subversion or your version control. And of course, it's Maven only. So we have in Artifactory, and that's actually pretty new, and it's coming up in the next release of the plugin. We have a release alternative, and this is what it does for Subversion. So it supports Subversion and Git at the moment. I will show you. It changed the descriptors to the next version. It compiles and tests, creates the tag from the working copy, moves to the next development version, and commits the new descriptors. And finally, it deploys to the repository. So it's a much faster process. If we look at Git, so Git is a little bit different. So it looks longer, but the thing is that with Git, a tag is really a tag. So you need to create something for this tag to point to. So for Git, it creates the local release branch. It changes the descriptors to the next release version. It locally commits the tag and the release branch. It compiles and tests, checks out the master branch, changes the descriptors to the next development version, and it pushes all the changes to the remote repository. And finally, it publishes the binaries to Artifactory And the advantage is it's fast, it's quite easy to roll back, so tag removal will happen automatically by this plugin. It's closely integrated with the CI server, so it's reusing all the definitions that are already done in Jenkins for Subversion or Git or whatever, or Gradle. It supports Gradle, and we have support coming up for Ivy with Jenkins and for TeamCity and Bamboo. So let's see a demo of that. So if I'm going back to Jenkins, wow, that's not good. So yeah, the VM died. Okay. 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 So let's go back to this build. And as you can see, this was an Artifactory, a build that was deployed to Artifactory, so I have the build info there. I can go to Artifactory to watch it. But what I want to do is I want to stage a release. So let me show you the configuration for doing that. Okay. So this is very Gradle specific. Here it is. So some of it is. So first of all, I check the enable release management. And this is generic, so it can either be a VCS URL if you're using Subversion, or a tag, a prefix for the tag. Then I have the prefix for the branch, which is Git specific. And in Gradle, there is a file called gradle.properties. So let me, yeah, okay. Okay. So I have two properties here, which are used by my build. So we don't assume anything about the build. We say, just have this properties file, and in your build, you do whatever you wish with those properties files. So my build is actually using this to set up the version of my project and the release status of my project. So currently, it's integration, and it's a snapshot one. And in the plugin, I'm telling him, I have a couple of types of properties in my build. One is a version one. So that is done. It is done because the plugin would be smart enough to guess the next version if I tell him that this is a version property. And this is the just additional property that I want to change in my release. So once I stage a release here, so I get this UI that auto-guessed the version property. So this would be my release version. This would be my next development version. And for release, I'm going to change it to release. And it will create this branch. And I'm going to put it in the staged release repository, everything that I built. And so I'm going to stage 115. Now I'm going to build, and so it's going to kick in a build and release to Artifactory. So I'm going to look at another one which I just did. It should be running, yeah. So let's go to this one. Actually, let's let it finish. Yeah, it's quite quick. So if I'm going back to the build in Artifactory, and because the VM died, I'm not logged in. Sorry about that. So let's see the published artifacts. So I have my IV XML here, which was published by Gradle. And if I view it, I can see that it has a release status, and the version now is 115. So it did the release automatically. And I also have the release history here, which tells me which repository I released to. And by whom. So I'm using anonymous, it's not very nice. And the comment that I put. So from Jenkins, I can go on and promote or demote this release. So I can change the release status here. So I can say I'm rolling it back now. I found performance integration, regression. And I'm going to put it in the rejects directory. I can actually include all the dependencies or just make a copy of it if I don't want to move. And since Artifactory stores everything by the checksum, the copy is really cheap. It doesn't do any real file system moves. So I'm updating it. So it's going to perform it now. And yeah, so now I have everything in the release history. So it's rolled back. So it's just the first incarnation of this plugin, and it will be further developed.
What does it mean to roll something back? Because my concept of once you publish an artifact, it's published in immutable.
Right. So you don't really.
Grabs that artifact and you rolled it back and it's gone.
Right.
The whole value proposition of these artifact repositories seems damaged.
Okay. So,
Yoav, can you repeat the
yeah,
question?
I'm
please?
going to repeat the question. So the question was, what is the real meaning of rolling it back, because it's already been exposed and consumed by people. So by staging, it doesn't mean that it's consumed publicly. It's all a question of visibility. So when it's consumed, and this is why it's staged and not released. It's consumed by QA, and QA may say, okay, this is not a good release, so just roll it back, and you can discard it from the rejects repository or do whatever you want with it after, but it's not going to be publicly visible. So if I would want to actually promote it, so I would be able to go to Jenkins and say that I want it to be released now, and I'm moving it to the releases repository. So these are just repositories that I created ahead, but it's just a matter of visibility, promotion, demotion in the world of binary artifacts. So it's who can consume them, that's all.
And I'll try to and what happens to the release number? Does that get reused or is that used up? It's gone.
It's used up. It's used up, yeah. So it should. The release number is not being reused ever. I mean, you can, but you shouldn't. Yeah, okay. So we agree. Okay, so going back to my presentation. Okay, so I'll try to be really quick with this one. This is a really common problem of release isolation. So you build integration builds in parallel, and the easiest way to grab this is that giving just this visual example. So there is a job that creates job number 12 that just ran. It creates artifact 12. Then there is job B, which is running maybe a very lengthy integration test that creates artifact B4. And the only reason it created this artifact is because it resolved, it was a downstream build of job A. Now, what should happen with job C that runs after job B completed is that it should grab A12 and B4, and these are the good artifacts that really caused them to be built. But unfortunately, another job kicked in because it picked up a new commit to the version control system, and remember that job B runs for quite a few minutes. So instead of grabbing, it has a dependency on the latest artifact, right? So instead of getting the latest, instead of getting B4 or A12, it's getting this new A13. So this is what happens. Job A13 created A13, and job B is going to take the latest one, so it's going to take A13. And the release is completely busted. You're building something that was never meant to be built. And this is a really pain point that we see with a lot of customers. So what we do is, and it's a combination of the plugin and of Artifactory itself, we paint the build. So we put on the build, we mark the very first build in the chain with a build info property. So the resolution to Artifactory always looks like that. It has the extra matrix param. So this is actually a standard HTTP query, not very known, but it's a standard way to do it. I mean, it's in the spec. So just to show you in Jenkins, I'm not going to have time to go deeply into this example, but So let's say that I have this common that has dependencies on core. It downstream builds. It has a downstream build core, and core itself is downstreaming up one. So in the common one, all I have to do is check this box, which is enabled by the plugin, and it's going to paint the resolution. And by painting the resolution, I mean that if I was to look at the core build and look at the resolution output of it, so this is actually a Maven build. So I can see this root, this build root property as part of the request. And effectively for Gradle or for, which is using Ivy. So for Gradle, if you have, if it needs to know the latest dependency, it will generate. Gradle is, it basically queries, depending on the resolver, but it basically displays the HTML page and looks for the latest version in the hrefs. So it's kind of dirty, but this is how it works. With Maven, it generates an Maven metadata XML that has the latest version there. And when we see this property, we trick and we generate a Maven metadata XML that gives you your latest version, your isolated latest version. So we actually solve this problem. So we've seen that. Finally, I want to talk about license creep. So it's a very common problem, especially if you distribute your software. And the information is there in the descriptors. I mean, it's very common to have license information in descriptor files. But it's not being very widely used, all this information. I mean, people can put it, but it's not, since the information is kind of slack, so people are not really using it. So I want to show you what we did. So it looks kind of scary, but the flow is actually very simple. So there is somebody declaring a new dependency, that's step one, and commits it to the version control. Then your build server would take this change and start a build. And finally, as part of the build, it will resolve from the repository and deploy to it. So what we're doing at the moment that we're deploying, that somebody deploys, so if you remember, we sent this build info file to Artifactory with all the build materials. It will analyze the descriptors, the Ivy descriptors in this case, and it will try to find license information in there based on various rules. And then if it finds something, it can alert you about license violations. So let me just show you, it will make it much clearer. So let's drill down to one of those builds here. So this is a sample build. And as you can see, I get a small summary here at the top. So I have 12 unapproved artifacts, 4 that are not found, and that's it. So if I group by license, so I can actually see in my build all the licenses that were used and the actual artifacts that were using them. So just to see how it works behind the scenes. So this is Apache 2. And since the information is slack, we had to fine-tune it with regular expressions to find out. We actually tuned it against a lot of open source builds. So we find out the license information from the descriptors. In the case of Maven, we actually go up all the way to the parent POMs and search. And of course, you don't have to accept what the auto-find decided. And by default, no license is approved. So if I approve this Apache, then I would get a different summary. So now I have only 4 unapproved. And you can say, this one is not Apache, so you can decide whatever license that you decide it is. And it sticks by the checksums. So no matter how, Artifactory is very checksum oriented in how it stores stuff, so no matter how you move the artifact around, this license information or properties will stick with it. So finally, on the Jenkins side, so me show you. So there is this flag, run license checks. And the nice thing about it is that you can just specify an email, which is usually not the legal personnel. So you want, the minute somebody committed a new dependency to your project, you immediately become aware of it and you get a license. And we ourselves, whenever we just update, and we use it to build Artifactory itself, whenever we just update a new version of something, we're always in shock to see how many new dependencies it brings with it and how lengthy this email can be. But the nice thing with it is that you can tend to it early on. So you don't, normally you want, at the end of the day, you have this really annoying process, not with every organization, but you have to go to legal and hand them this legal sheet and explain to them why you're using this software or why you're not. And it's much easier if you get the information early on and you can decide whether you need the dependency or you need that to be using this license and so on. So that's something else that a repository manager can give you. Yeah?
Do you check for compatibility between licenses?
You mean if you have multiple licenses or?
Yeah, if you're plugging dependencies with different licenses and your project has certain license, do you check for compatibility between licenses? Like you're pulling a GPL code, but you're something else GPL.
Yeah, so the question is, do we check for compatibility of licenses? So per license, you can say whether or not it's approved or not. And based on that, you will be getting the email. And we, of course, also support multiple licenses. It's very common, actually, for projects to have multiple licenses, and it's up to you to decide which one applies for your organization. So we have this notion here of a neutral license. So if you have one that has multiple licenses, but you approved one of them, so the ones that are not approved are considered neutral. So you still get to see them, but they will not cause any violation alert. So I think I'm done. So just to iterate, I hoped I convinced you that using a repository manager is a much more powerful experience than just using Subversion or an HTTP proxy. And it really changes how we work, the whole domain. It's a brand new domain, maybe 2 or 2.5 years, and it's evolving. It's an evolving domain. So thank you.
Our next presenter is CEO of Gradleware and author of Gradle, Hans Doctor. Where is Hans?
Yeah.
Ah.
So. Oh, perfect. Hi. Enter the Gradle. No, 30 minutes. So, short overview. What is Gradle? Gradle is a general purpose build system. It comes with a Groovy DSL, but most of it is written in Java. It provides built-in support for Java, Groovy, Scala, Web, OSGI, and many other type of projects. But it's built on a general purpose build system. So this is just an offering you can use, or if it doesn't suit your needs, you don't use it. Gradle provides exciting solutions for many of the big pain points you often have with current builds. That's what we always encounter. It's maintainability, it's performance, it's usability. And for the one enterprise, one thing is the bigger pain. For the other, it's the performance. So, yeah, a couple of very prominent projects have switched to Gradle. This is just a subset: Hibernate, Spring Security, Spring Integration, Groovy, Grails, C4J, Mockito, Spock. So there's a big momentum happening, and yeah, the same is true for the corporate world. Okay, just some news. This year, Ken Seip, Peter Niederwieser, the founder of the Spock testing framework, and Stephan Faber, the founder of the Mockito testing framework, have joined Gradleware. We're very excited about that. Sonar support will be in Gradle 1.0 milestone 2. So we're cooperating with Sonar Source. We paired up with one of their developers to make that possible. There's a very helpful new DSL reference guide. So there was people rightly complained about some missing documentation bits. So that's, I think, a big help. Also very exciting, the Spring Source STS team has started to work on a Gradle plugin for Eclipse. So, the first prototypes are out, and so expect something to be released within the next month. And something really, really good, because those guys are rock stars. They're doing a fantastic job. You will be able to import Maven projects when Gradle 1.0 Milestone 2 is out in the next days. So that's another nice feature for partial migration or for giving Gradle just a try without spending much effort into it. Yeah, and we will continue to have 4 to 6 weekly milestones towards Gradle 1.0. Okay. So let's start. In the seats at the end, can you read what is on the screen? So is that better? Okay. So what do we have here? Just a couple of lines of Gradle code. We just tell Gradle, hey, this is a Java project. Get your dependencies from Maven Central, and those are the dependencies you need for compiling the code, and those are the dependencies you need for compiling your tests and running your tests. Okay, and just by telling Gradle that this is a Java project, you have already, you have a full life cycle to build a Java project. So, so you can now say build, and just by sticking to certain conventions, like your source code is in source main Java, your test code is in source test Java, that's all you need to do, and your project is built and tested. And the conventions not just apply to the input of the builds, they also apply to the output. So you now have a build directory with a libs directory, and your jars have a certain naming pattern, etc. So yeah, so far so Maven, right? Okay, so let's play around with that a little bit. Oh, sorry. Okay. Let's add the requirement that we need a couple of more jars, right? Oops. Let's grab them. Let's add them. So a jar that contains all the sources, a jar that contains the compiled test classes. The Java plugin is adding a default jar. We just tell the default jar, hey, don't include any Spring-related classes, right? But put them in separate jars. So my Spring classes that are related to the database layer are in that jar, etc., etc. So I want to modularize that for a particular reason, right? I have in my domain logic. So I'm not longer using the idea runner because it's not as fast as when we do it from the command line. That will be fixed soon, but I'd rather do it from the command line. So we can now say Gradle clean assemble, and Gradle will automatically picks up all the jars that you have declared, and if we go to the build directory, here we go. All right, okay. So again, and you see there are naming conventions. So you said appendix is equal SpringDB, so the naming pattern is name of the project, which is rules. The appendix is SpringDB, the version, and the extension, right? So again, built by convention in place. Okay, now I have some news for you. I don't know if you heard about that. You probably have, that Spring Source has changed their license agreement. So what do? They have the new agreement that if you have a jar that has the name Spring in the file name, this jar must contain a picture of Rod Johnson in the meta-inf directory. Here we go. So, yeah, Yeah, and now you have pressure. You have to implement that, right? So let's see how we can implement that requirement with Gradle. So, okay, for all tasks.
This wasn't meant to be public yet.
I haven't signed any NDA. I just eavesdropped your conversation. I'm sorry. I thought people are interested, right? So, okay. So all jars matching the following criteria. Jar name contains Spring, right? For all those tasks, just say jar. Oh, now I have to think. Meta-inf from source icons rot JPEG. Okay. Was not that hard, right? So let's give that a try. Let's do a clean and rebuild all the jars. Let's have a look at one of the Spring DB. Oops. And you see, right, pictures in the meta-inf. Let's do it with a non-Spring jar. Rod's picture is not in the meta-inf. Right. Okay. That was requirement number 1. The problem is QA is really worried. The violation fees are very high, so they want to have some easy way to check, to build all the Spring jars and check whether they oblige to that constraint that the picture has to be in there. So how do we provide that to the QA team? This task. Okay, let's do this. All Spring. Let's introduce a variable. Call it all Spring. And this is a rich domain model. So this actually returns an object of type task container, right? Which has a live filter on all the tasks that are defined, and the filter are the conditions we have defined. So this hasn't changed anything, but now you can say, I create a task with the name Spring jars, and I just let it depend on my all Spring container. And oops. And you see camel case execution in action. Oh no, Spring jars was just the name. And here we go. You see only the Spring jars are built, right? So usually I add a couple of more details to this example, but we don't have that much time today. To tell you the truth, SpringSource hasn't changed their license agreement. But I think it is a very typical example for a requirement in an enterprise automation context. There are always requirements like that. Requirements a build tool can't anticipate. You know, this is just, you know, there is a lot of craziness going on, and some for political reasons, some for valid technical reasons. Just build system authors don't know about. So we think a build system should just embrace that fact, right? That there is a lot of stuff it can't anticipate, so it should provide tools to the build masters, to very sharp tools to express such requirements, and we have just seen one. Gradle has many of them, you know, to capture easily even challenging custom requirements you have in the enterprise. Okay, and the way we do that is by providing you an extensible build language. So if you look at this flower, there are build systems that only provide you the molecular level, like AND. Or there are build systems that only allow you to say, hey, I have a rose, I have a tulip, right? What Gradle tries to do is to provide you the proper abstractions to build your own flowers. Gradle, on top of that, comes also with roses and tulips. but we know you are in the Amazon jungle, and there are many undiscovered flower species we have no idea of. But we know that in most cases you can model them with some basic building blocks. So, and that's the idea of providing you a build language, making it extendable, as you have seen with the jar example from the slide before. So that way you can tailor the requirements of your enterprise. And usually, of course, this stuff here doesn't end up in the actual build script the normal developer is using. This rules here would be written and hidden in some enterprise plugin, and they make it completely transparent to the developer. There is no wiki page what you have to do if there is a jar with the name Spring in its name. They don't even have to think about it. You enforce that behavior, right? And it's completely transparent, which makes it extremely foolproof, because people don't have to pay attention to such a rule. It is just applied because you have extended the Gradle build language. There are many ways to extend that build language. That's just one example. Okay, I'm aware that you can't read that, and it's not important. You see, it's a lot of stuff, right? We have one of our first massive corporate users. It's Carrier, the air conditioning maker, a subsidiary called Automated Logic. They're doing building automation. And they have a large build, but most of all, a very complex build, because they really have to ship CDs to particular buildings with distributions tailored for particular buildings. So they have a couple of 100 modules, and they have very complex workflows to assemble distributions for their users. And that was necessary for a normal developer to add another submodule to the code base. That was their AND build framework. And on the left, you see all the different files people had to touch and all the copy and paste they had to do. What happened, and this is no joke, people stopped adding other submodules. It was a serious problem. If they did, it was very error prone, and you don't want to ship the wrong distribution to your client. There's no way you can provide a hotfix and stuff like that, right? So for them, it was mission critical. We have seen many examples where companies were in serious problems, mission critical problems, because their automation was not working. So yeah, and they switched to Gradle. When Gradle was at 05, I was saying, wow, that's brave, but it worked out for them very well, because that's what a developer has to do now to add another submodule, right? Because they extended the Gradle build language, they could add their own, how does this guy work? They could add their own language elements, like this is a product, and it is completely unclear which of those language elements are shipped by Gradle itself, and which of those language elements are added by their own enterprise plugins. In fact, when they invited me to have a look at their build, and then they were feeling a bit awkward, and I didn't know why. They were saying, well, you know, our developers don't know that they're using Gradle. They think they're using our custom build system. That's the way Gradle is supposed to serve you. It's for you to extend it, to tailor the requirements you have, and to make it extremely easy for a normal developer to work with the build. Of course, what is hidden behind those plugins is very complex stuff. I mean, we can't take away the complexity of the domain. It is just complex. We just provide you the right tools that the complexity is hidden from the people who should not be exposed to it. Okay. Oops. Oh, that was my last slide. But there's more to come. Okay. So, which one do we use? Okay, test me. Again, a very simple Java project. The difference to the other project, it has a lot of tests, right? A lot of test packages. So, just let's run them. So one thing you can see is we don't use the command line as a poor progress bar, right? Like in the end, when you have 4,000 unit tests, you have 4,000 lines of code in your build output, well, have fun to look for the warnings, right? which happens at other places. So, okay, so we will also invest a lot in the future to make the command line output smarter and smarter, to give it some history, some awareness, how long it took the last time. So to make the dynamic command line output better and better, we are very ambitious about that, and that's just the state where we are at. I think it's already pretty helpful to have a very, very clean output, but there's more to come in that respect. Okay, so there are always those developers that check in unit tests which take too long, right? And especially in multi-project builds, they often only pay attention to the unit tests of their project, right? And so they don't bother if it takes 3 seconds more. But when you have many submodules, that adds up, and your overall build time is getting longer and longer. You don't want that. So, okay, let's do something about that. So, okay. Here we have a variable long runners, just a list, a Groovy list. And then we hook in a listener into the remote JVM that is running the tests, right? And this listener is notified by the remote JVM after each test it has executed about the description of the test it just executed and the result. And then we can do stuff like, hey, if the actual time for executing the test is larger than 100, then issue a warning and add the name of the test to the list. After all tests have been run, write a little report with the name longrunners.txt and just list the name of the tests that are long running. Okay. Let's do that. Okay, 2 tests are long running. And if we look at the output, we see here's the long runners text. And those are the name of the test. That was easy, right? Again, this stuff would usually not be in the concrete build script, but hidden in some plugin. But you see how easy you can hook in via the Gradle Steep API into the execution lifecycle. Just let one test fail. Just let's throw some runtime exception. And let's do something else. Let's hook in another listener. What does this other listener do? It checks, was the test a failure? Then it figures out the location of the XML results file of this failing test and opens up TextMate with the result. Let's see if that works. You see a test failed, and here we go. TextMate. You see? And this happens immediately after the first test fails, right? And you see, if a test fails, the output is preserved, right? So this is not dynamic output. This belongs to the important output of the build. To tell you one other example, you know Sabre, I don't know, the company Sabre, they have a big lab in Krakow, and Stepan Faber, the Mockito founder, before he joined Gradleware, was working for Sabre. And they had the following problem. They had a very complex and very important test which exposed the following behavior. When you run it the first time, it always failed. When you run it the second time, that was the important one. When it then failed, the test was considered failing. When it succeeded, it was considered succeeding. So you could argue now, well, that's not the way it should be. Well, you don't have to tell Stepan. I mean, he is an absolute expert when it comes to testing. I guess most of you know Mockito. So he knows that. But he couldn't solve the problem. It was related to infrastructure stuff he was not in charge of. So what would he do with another build system? Disable the test, right? Because the build system were not anticipating this kind of problem and were not prepared to do the unanticipatedness. Whoa, that was difficult. So you can see how easy that would be with Gradle, with all the test listeners. You just do it in 10 lines of code. Try to do this with Maven, try to do this with Ant, right? And what really, in general, gets up my nose are arrogant tools, you know, tools that say, you shouldn't do it like that. Well, but this team that is failing the test, they don't like us, and the project lead is the son-in-law of the CEO, whatever, you know, politics. You can't do anything about it, you know. This is the reality of the enterprise. You don't need some arrogant tool telling you this should not be the way it is, you know. You need to have a solution. The tool can offer you an opinion, but at the end of the day, it should be your humble servant, period. You know, I don't want to argue with the tool when I need to solve a problem. That's ridiculous, you know. And, you know, I'm still burned by EJB2 container managed persistent. That was, yeah, you know, this, yeah. This is, I guess, my therapy, right? Yeah. Okay, so, some time left. Okay. Performance, one of my favorite topics. Let's have a look at this project with the name Foo. Again, a standard Java project, right? Source main Java, test and source test Java. Let's build that the first time with the clean. And how many of you always do a clean when they use Ant or Maven? For two reasons. The compile is not very reliable, right, when you don't do it, and you don't save much time when you don't do it. When you don't do a clean, still, all the tests are executed, all the archives are built, so why taking a risk when you don't get much benefit out of it? Well, we think you neither should take a risk, right, and you should get a lot of benefit out of that. So let's build it without a clean. Oh, everything was up to date. 0.7 seconds. Yes?
How do you deal with cross-artifact transitive dependencies?
Well, if the class path has changed, I have to recompile.
Repeat the question, please.
How do we deal with across multi-project transitive dependencies? Well, they affect the class path, right? So if I have a dependency on that project, it means it is my class path, for example, for compiling, right? Is that your or maybe I don't understand your question.
Is there a mic, sir? So if is this on? Yeah, okay. So if something that I'm dependent on, say one Java class changes a signature or something,
Mm-hmm.
I don't need to compile everything that's because of the class path. I only
Yes.
need to compile the affected modules, which would be a transitive dependency check. Now, I don't know.
Okay, so there are two things. Of course, in a multi-project build, well, I don't agree. So if I have a dependency on that project, and you have changed a class in that project, it means my class path has changed. So I have to recompile. Right? So if B depends on A and you have changed something in A, the class path of B has changed. I agree with you. You could be very smart with a really smart incremental compile. We don't have that yet. So you could invest into, first of all, into an incremental compile of A, right? So not compile the whole thing like we do at the moment if something has changed, but analyze the full dependency graph and stuff like that. And then for B, you could analyze even the class path and figure out what in the class path has changed, which classes in B are affected by that change, and then make a really smart incremental compile. And at one point, Gradle will do that. The thing is, there are so many other performance improvements we can do which have a higher effect than that one that we still postpone it. But that would be a smart incremental compile would still be a gorgeous feature. And at one point we will offer that. Okay, so let's change this class. For example, let's add a new field with what's going on here? Variable. Okay, let's rebuild it. And you see, Gradle picked up the fact that it has changed, has recompiled, has rebuilt the jar because the bytecode has changed, right? The class path for the tests have changed, so that the tests need to be recompiled and re-executed. So let's do something else. Just let's add a comment here. Again, Gradle picks that up, it recompiles, but the jar is up to date because we use checksums, right? So, and so nothing else needs to be done. It is even sensitive towards the output. So I can say remove build classes main. I remove the output of the compile, re-execute, stuff is recompiled, but of course the bytecode hasn't changed again for the other tasks, so everything is up to date.
One thing, jar files often have timestamps in it.
Yes. Yes, that's a problem. And in particular, if you have a dependency on that timestamp. So we are not smart enough yet, but what we want to do is, if you have a dependency on another project, don't use the jar in the future for compiling, because you don't need the timestamp, right, for compiling. Use the binaries, and then at least your dependent project wouldn't need to get recompiled. So this will come in the next month. So good question, yes. Therefore, we do this in Gradle, and therefore when you do a snapshot build, the incremental build is only showing 20% of its potential because of that. I agree. Yeah. Okay, so one interesting question is now, well, how can I use that for my custom code, right? This is built-in Gradle stuff. So let's have a look at that. Here we have an XML file, mountain is XML, and we add the arbitrary requirement, hey, for every mountain node in that XML, create a text file which has the name of the mountain in its name and has the content, the height, right? So just let's grab this guy here. Let's add this file. Going a bit crazy with scripting. Let's not get into the details. This is just some groovy stuff. Let's execute, generate mountain files. Camel case execution. Here we go. Mountains directory is here. K2 text, Mount Everest text. Okay, so how much faith do we have in Gradle? Will it be up to date or not? Well, I wouldn't ask that, right? Otherwise, oh, rebuild. Something is wrong. Rebuild. Damn. I want to make you independent personalities. No. Yes. On the other hand, it would have been an impressive achievement analyzing an arbitrary amount of Groovy code and figure out what is the output and the input of that task. Impossible, right? Beside that, I don't like this build script. We in Gradle pay a lot of attention to having clean build scripts which are more like a spec, and I don't want any scripting craziness happening, you know, in the high-level section of my build file. You know, imagine you would have 5 of those tasks with 10 lines of code in your build script. You completely lose the ability to easily figure out what is going on. So let's provide a simple solution for that. Do copy and paste. So let's, oops. So we now create our own task type, which does the same games, you know, generate the text files. It has now certain properties, XML file, separator, output dir, and here we create an instance of that task type and configure it. This is the output dir, this is the input XML, and this is the separator. You will see soon why I did that. So this build script is much cleaner to read. The imperative stuff is now clearly hidden in a class. This class could also live in a jar. And the high-level aspect of the build script is very expressive and nice to read. Okay, that's one benefit of that. The other benefit is, let's do a clean first. Let's run it again. It's up to date, right? Because you have now defined the input and outputs. And this is typical for our philosophy. You did not tell Gradle anything about incremental build. You just told Gradle, hey, this is the input and output. You could go home and you have understand the concept. It's extremely simple, but extremely powerful. This is, again, we try to provide you a rich model where you can tell us the what of your build. And we can use that information also for making a very smart parallel build, right? We can, from that information, we know, hey, 2 tasks are writing into the same output directory. Well, we shouldn't run them in parallel, at least not if one task is deleting this output directory. But so when we are not quite there yet with the parallel build, but we promise you something. You don't have to use a synchronize keyword. That's not your job. It's not your job to parallelize the build. Your job is just to tell us all the relevant information that describe the domain you're modeling. The rest will be figured out by Gradle. So that's our philosophy. And just one thing, this is just a property. This is not a file that Gradle checks, but Gradle also keeps the history of the property. So when you change the separator to semicolon and you execute the build again, it is re-executed, and now we have a semicolon as the separator. One other thing you get from describing the what of your build, you can now easily say Gradle clean generate mountain files. And you see the mountains directory is deleted. You get this? We can do that because we know the output directory, right? Or you could specify a file which doesn't exist. You don't need to have any if blah, 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 then throw exception, right? If path doesn't exist. You just say generate mountain files. Gradle know this is an input directory, an input file, so it automatically does the validation for you. This XML file specified for property XML file does not exist. Okay, and you see, you don't need to create the mountains directory, the output dir. If it is an output directory, Gradle automatically creates it before the task gets executed. So it's just all about rich object model. If we capture the right information, and then we can do a lot of good stuff for you without, and you don't have to pay any price for that. Okay. Yeah, there's much more we want to do in regard to performance. We want to use the cloud. So one of the big pain points we see are integration tests. They are often the bottleneck. So being able to execute them in a distributed way would provide a lot of benefit. So we are very concerned about performance. We see this as one of the major problems, especially of the teams that are very ambitious and very capable in regard to project automation and software development. They have this huge chunk of treasures that can give them feedback. Now it's trying to find a way that this feedback can be given very fast, right? Okay, last demo. Okay, multi-project builds. This is Spring integration, which is using Gradle. And if you ask Gradle, hey, what projects do you have in that multi-project build? You get a list. Those are the projects, right? So let's switch to one project, Spring integration file. Let's build it. And one thing you can see is that Spring integration file has a dependency on Spring integration core. So Spring integration core is automatically built, right? In Gradle, you can explicitly define, I have a project dependency on that other project, not like in other build tools where you just say, hey, I have some external dependency, right? And it has to be in a repository. So let's say you've done a change to Spring integration file. You have run Gradle build, all the tests are running of Spring integration file, etc. This is all up to date because I did it before, but you get the idea. Do you feel confident now to commit to version control? What is the T-shirt from JFrog? What was the slogan? Yeah. Yeah. Well, let's see if that is true. Let's ask Gradle to build integration file and all projects that depend on integration file, if there are some. Yes, there are some. SFTP and FTP. And now you also build them and tested them. Now you know you're good to commit, right? But it saves you a lot of time because let's say you have a project graph of 300 projects and now you only needed to build a subgraph of 30 projects, right? And yet you have exactly the quality of feedback you were interested in. You haven't broken anything downstream, right? Now you can commit much faster than without that feature. And it's a very interesting topic, binary dependencies versus source dependencies. So this is stuff you can capture before in the pre-commit build. If you would have binary dependencies between the projects, you would have just checked that Spring integration file is fine, and then you would have to wait until CI would have figured that out, that something was broken. So we really like, in many scenarios, project dependencies. The only problem you have has to be fast enough. Right, we have one client that has a build with 680 submodules, more than 10 million lines of code. There it starts to get a challenge. But we are developing stuff to tackle that. And I think the king of all is Google with one physical source directory for their whole build. This is such an incredible achievement, what they're doing. And they know why they're doing it. This is because they want to have integration pressure. So this is not possible in the enterprise always, you know, the son of the CEOs when they're around and don't like to write tests, but yeah. Okay, the last, some final remarks. So Gradle is a build tool, yes, but we think way beyond just doing the builds. You know, just building the jars and the wars is the easiest thing you have to do in the whole continuous delivery pipeline. So, a last story, I know I'm running out of time. The good thing of this last story is 90% of the story can be told in one word: WebSphere. It's a very big build. The stuff that needs to be deployed has 637 megabytes. And this company has now a really big problem. Because, first of all, the build was taking 5 hours. Now, with Gradle, average build time is down to 20, 30 minutes. When they get new hardware and solid-state drives, that will do will give another big benefit to their performance. But the biggest bottleneck is QA. When QA is figuring out, hey, I want to test this new archive, it takes at least a day until they can start with it. So we can do some stuff to make deployment faster, but it will always be, for certain reasons I've just mentioned, rather 1 or 2 hours. So what can you do? This is the reality of that enterprise, right? They don't switch to whatever to make deployment faster. What they also generate as part of their big archive is what they call a business report. This business report contains all the new features that have been added to this archive. And based on that business report, you can now make smart assumptions about which of the archives should be deployed to which QA machines. They have 10 different QA machines, right? So by going beyond build, by saying, hey, there's not just an archive to deploy, but to this archive there also belongs a business report, right? Both lives in the artifact repository, which is Artifactory, which will be Artifactory in their case. And then Gradle can make smart assumptions about what will be the next archive on which QA machine, right? And can do preemptive deployment. It's no longer a pull model, it's a push model, and that will completely be a game changer for them, right? Because that will reduce the average deployment time to minutes, right? Because usually it's already there when they need it. And yeah, so there is so much stuff in every enterprise which is beyond simple build and which is still done manually. They do it at the moment all via email, right? I need this new jar or ear deployed, they send an email to the deployment team, etc., etc. There are 20, 30 people involved in that game, right? Which is a job, they could add much more value by doing other stuff. Yeah, that was my final story. Thanks a lot for your attention.
Thank you, Hans. So our last presenter for the night, excuse me, far from being the least one, the Jenkins project lead, Kosuke Kawaguchi.
Thank you. So I guess I wanted to do some updates of the project status today instead of, I guess, doing the technical deep dive like, say, Hans did. So I hope I got the right audience for that. So quickly about, I guess he didn't like this slide somehow, huh? Oh, I think I know what's going on. I think, yeah. Oh, phew. So, I think around the last fall, I think we had this infrastructure issue in the hosting of the Hudson project on the Java.net. And that quickly turned into a broader question around the control of the project from the Oracle. In particular, the issue was that the trademark, that the Oracle said they own the trademark, and so you got to do it our way or the highway. So that led to discussion between us, the key people in the Oracle, the key people in the community with the Oracle and offline to try to arrange a structure. In particular, we tried to move the trademark to the custody of the third-party neutral foundation, I guess, like say Software Freedom Conservancy or Apache, or that kind of foundation in an attempt to create a level playing field. But eventually, over the few months, we regrettably came to the conclusion that the negotiation had failed, that things didn't work out. So we moved on to propose a vote to rename the project from Hudson to Jenkins. So that was the January of this year. And that vote was subsequently approved with 214 to 14 votes, and with more people in Twitters and the Hacker News and the Reddit overwhelmingly supporting the move. So that I called, I guess, now that this is over, I can now imagine what the divorce experience is like. It's a painful, stressful experience over a few weeks. But now that it's over, I feel much happier, and like the world really looks rosier and the skies are bluer. So, the project has since then moved on to the JenkinsCI.org. We had the assets under the community's control. So it was, in some sense, it was an easy move. We appointed 3 people in the interim project governance board. It turns out that all three of us are here. Myself is found in the Andrew Bay from Cloudera, who's sitting there, and the Dean Yu from Yahoo. So that was, I guess, the ultimate sort of decision-making board. And in practice, what that means is that we get to do all the grunt work. And we're also in the process of registering trademark, even though I don't think this time there is any risk in having someone claim that, but we just had this bad divorce, right? So you better be sure about that. And then we are seeking the umbrella organization that sort of, again, like the foundation, like the Software Freedom Conservancy or Apache, that sort of creates a bit of legal structure around us to hold assets like trademark or the domains, to consolidate the copyright and the contributor license agreement, and so on. So in terms of the development in the core, most of the developers have moved on to Jenkins. And then so this was something that we are trying to communicate across, and we get a number of feedback that, okay, so what do you mean by most, right? It's a subjective term, and we need, you need to back up the claim. So now I don't really want to spend time like talking about my ex-wife in a way. It's just like not something that I feel like I should be doing. but at the same time, people are asking this. And then so in particular, Shiromi convinced me that this, you got to do this once. So I'm trying to do it here now. So, so we got, since the divorce, we had these more than 700 commits inside the Jenkins, and then compared to the 170 on the other side. So that's a lot of difference. And one thing that I like particularly about that is of those, the 700 commits, the 42% of those is done by people other than me or the outside the CloudBees. And that's compared to the 1%. That is the 99% of the changes in the X5, it's still happening by their owner. And then also, similarly, those changes in the Jenkins side was made by 48 people compared to the 7 on the other side. And of those 7 people, I think the only 1 person has committed in the original, pre-divorce Hudson code. So, so that was one stat. And then I think the interesting thing happened was perhaps partly because of this publicity, or partly because we moved to the GitHub, we actually saw the increase in the contribution. So we are always obviously kind of worried that if the community splits in two, each gets lesser amount of contribution, but that's apparently not the case. So we processed at this point we have more than 170 pull requests processed yet, and compared to the 20 on the other side. And before the split, we release the project releases a new version every week. And then typically, the 10 release before that divorce has happened, on average, we have 6.7 changes per release. The thing that we list, the important changes that we list in the release notes. And that showed up to 11.3 after the divorce. So that's sort of showing the amount of new contributors coming in and making changes to the code, which I think I really like. And then the project has the 94 publicized committers. So the GitHub had this interesting idea that the people could be member, but people could sort of shy away from showing their identity. So I think we are actually double this number, but the 94 people you can actually count by their name on their GitHub organization. And that's compared to the 4 that we have on the other side. And then we have the 496 repositories on GitHub because we have everything on there now, well, except some Subversion repository we have back there, compared to the one on the other side. So there's a lot going on the Jenkins project. And then that's also true. The same story is basically true on the plugin side as well. So most of the plugin development has indeed moved on to Jenkins. So now one of the things that, I guess this is the laser pointer? Or well, I guess it's too high tech for me to figure out. So one of the stats that I found interesting was this is the number of commits that was happening on the XY side. Right? In January, there was a massive back import from a repository back into the repository, so there was a number of commits there. On February, I see some trace of people trying to make the changes, and then the March that died down to just one commit for the whole month. And there was another person who did a very in-depth research on what happened to the top 25 plugins, the top 25 in terms of the installation base. And he found that the 21 of those has moved to Jenkins, and 4 of them didn't get any changes since the divorce. So all the plugins that are getting changes are now happening inside the Jenkins. And also, since the divorce, we added 40 new plugins to the arsenal of 350 or so plugins that I stopped counting at some point. Compared to the one on the other side. So I think the story is quite, I guess the story that I'm trying to portray here hopefully is pretty clear now. So all in all, I guess between those core development and the plugin development, I think we are delivering what the really users needed, the iterative improvements, the bug fixes, the sort of something that preserves their existing investment into all the data files and configurations and whatnot that people have made. And so, we've added new installers for Windows, and well, I guess I shouldn't go into the technical details here. But, we keep on basically following what made the Jenkins project great. That is this model of the releases, the way people work. There's a certain social or the cultural structure built into the project, and we are true to those traditions. And so the bugs are getting fixed, and the features are getting implemented after the divorce. Since the divorce, we had the 282 tickets resolved compared to the 68 on the other side. And the 514 ticket was created by various people compared to 129. So we are getting work done. And I think the people are seeing that and following where the action is. So you can see that the number of public Hudson instances is moving to Jenkins. And given that we only have like what, the 2 or 3 months after that divorce happened, those upgrades of these sites at this scale takes a lot of time. So I was quite pleasant to see a lot of sites like Apache, JRuby, NASA, Scala, and so on and so forth, already moving to already has finished moving to Jenkins. And then the traffic in the user list, that's where we do the primary user support. Is also showing a very startling difference between us getting the 1,200 emails that we need to, we need to answer. So it means more work for us compared to 259 on the other side. The download number, so I looked at the last week's download counts on our web server, and we don't know we don't have a comparable data on the other side, obviously. But we got the 8,000 people downloading raw files, and then 2,700 the Debian packages, and 1,200 the Red Hat, and then 1,300 Windows installers. So I'm kind of surprised that the Windows had such a low representation nowadays. But so you can see that these are pretty significant numbers of the binaries that we are delivering to the people. And also the Jenkins has been packaged, or the Hudson has been packaged into various operating systems by the respective maintainers. And then those installations are also switching. So the Ubuntu is now packaging Jenkins instead of Hudson, and so is the FreeBSD and OpenBSD. So again, the people who are, people are following where the action is, and I'm quite pleased with that. So this is the week-by-week chart of how many bugs are getting filed and how many are getting fixed. So toward the end of the 2010, you see that the traffic is going down because of the divorce is happening, and people are sort of like trying to stay away and see what's going on. But after that, it came sort of right back up in terms of the development and so on. So, and you can really see that there's a noticeable difference between pre and after divorce. So, things are, so as far as I can tell, things are moving pretty well. So there, I guess I've done my sharing of the divorce experience. That was kind of painful. And now I get to talk about the newer things that's going on in the project, which I think is more productive. So, since we had this experience, we made a number of changes and so on that are sort of bearing some fruits. One of them is that we are now hosting this bi-weekly governance meeting in the IRC, and then it's open for everyone to join. And I think we normally get to see like about 130, 50-ish people, depending on the day. Not that everyone participates, but so it's a very active forum. And we discuss the project issues, not the bugs and features, but the structure-related things that we should be trying, and so on. And the minutes are accessible to anyone, and so is the agenda. So initially, I have to say I was a bit skeptical about this idea of doing a meeting in a chat, but it turns out that this was very useful, first in getting the fresh people into the project. So there are apparently a lot of people who are interested in helping out the project, but just didn't know how. But this provides a venue for them to sort of come and then pick up the action items and so on. So we are starting to sort of, I guess, offload some of the grunt work to the different people, which is good. And then there's something in this IRC channel that creates a stronger bond between people, because I guess we talk about the silly jokes and so on, that sort of, you start to feel like you know the people, which is really hard feeling to create inside the open source project, because you normally only know them by name. So that's been useful. Another significant initiative that we are trying is this idea of the stable release line, the stable but order release line. So the model of this is that we've been kind of crazy in the sense that we are releasing every new version of the software weekly, and then so that in a way that served us well, that it allows us to deliver bug fixes quickly and deliver the changes in the core that the plugin developers need to make their changes. So that was our model, and it still goes through all our automated tests. We have, I think, the 800 or so automated tests that covers area in a decent fashion, and so it passes, and so we call them releases, but at the same time, there are enterprise users and so on who would appreciate more stability with the less frequent release cycles but who would like to get more stability out of the releases. So we are trying this new maintenance release line that branches off every 3 months from one of the earlier releases that we think are good. And then we'll only provide the backported fixes from the mainline releases in an attempt to control and avoid introducing regressions. And then we will keep that for 3 months before we switch to the new one. So I was just making first sets of the backported releases, backported fixes this morning. So hopefully the first version of it, which would be 1.401, would come in either this month or the next month. Well, more likely next month. So I think that would be interesting. Useful. I hope that will be a useful feature for many of us. I guess the part of the motivation for doing that, aside from serving users, is that there are many companies who are using Jenkins in big enough scale that they have a small set of people who's responsible for like certifying the inbound release and occasionally make some changes to it so that it has the right set of stuff inside it for the rest of the company to use. So they do a certain degree of QA on the inbound builds. So by creating this maintenance line, I'm really hoping to sort of be able to have them work on the same code base together, which should sort of help improve the quality of that branch line. And I think it makes more sense for that to be done in coordinated fashion than having everyone picking up the random versions. So this is a new initiative, so we'll see how it goes. But I'm quite hopeful that this will provide something interesting. And on similar topic of the stability and release, the stability theme, the Frederick Kambler is working on the new, I guess, the infrastructure work of massively doing the plugin compatibility tests against the more recent version of Jenkins. So he wants to rerun the plugin unit tests against the arbitrary version of Jenkins to sort of essentially create this matrix of compatibility tables. And we hope that that would allow us to catch some of the regressions earlier before it sort of wreaks the havoc in people's deployment. Or the another effort that's going on that I'm personally very excited is done by Charles Loyal about writing Jenkins plugin in JRuby. So as it turns out that originally Jenkins, well, obviously because it was implemented in Java, a lot of user base was around Java, but it's sort of now it's at the point that it's used as a dominant CI server in the PHP community and the Ruby community and so on. So now the problem was that those people, let's say, especially say the Ruby folks who who uses Jenkins, so when their usage hits certain point, it becomes, some of them would like to customize its behavior, and then the standard way of doing that in Jenkins would be by writing plugins, but because they don't want to do Java, they can't talk to their colleagues in straight face that they're writing Java code. So they got to be able to do that in JRuby, right? What Charles is trying to do is to enable that path. And then I think the part of the reason I'm excited about that is because that it create the new path for the users to become the developers in the Jenkins project. And then so that it create the interesting plugins, because those are the people who really know about how to integrate Ruby tools or the PHP tools into the CI server. So by taking advantage of their expertise, I think that we should be able to see a lot of new interesting plugins. That should hopefully bear fruits within coming months. And then I guess my personal focus in the core continues to be that the helping plugin developers, because nowadays the core really stopped to be a place where the new features are getting developed. It's more like a lower level enabler that allows the higher level people, meaning plugin developers, to do interesting stuff. So part of it is helping them technically. We need to provide interesting extension points that the people need to be able to hook into it. I was just talking to Yohav before this conversation and just identifying one more extension point. So we wanted to have that kind of conversation with many people so that we have the right hooks in the core to enable that. And then some of them could be adding more interesting technologies in the lower core to simplify the code that people need to write in the plugins. And then that in turn translate into bigger number of plugins and so on and so forth. And also part of it is the social help. So the hackathons, the meetups like these, the providing beta documentations and encouraging people to show up to IRC and things like that really makes a difference. I was just talking to a person who did the Mac OS X installer for the Jenkins. And then I guess we failed to catch his early email, but he was, I guess, persistent enough that he Fortunately, he talked to me, and so we discovered that we dropped that flaw. So, so that kind of thing is really important to get the project as a coherent, social structure. And so we wanna make sure that that keeps going, despite the fact that we have a lot more emails that we need to go through and whatnot. So I think that's a very important role that I have to do. And then obviously I got a lot of housekeeping grunt work that needs to happen. The modularity needs to be improved because the project has a longer history and that wasn't built in from the beginning. The plugin, this notion of plugin system came into the code base like several years after that. So after it was born, so we have to, I guess, retroactively create the plugins out of the core. So we need to keep pushing that. The bug fix is always important to keep users happy. I think that's the kind of thing that really makes a difference between happy users and not. And also the error diagnostics. I think in seeing how people use Jenkins, I discovered that one of the reasons people turn away from any tool, I suppose, is like when they are having trouble, like they get to see some stack trace and they couldn't really figure out what's going on. And we have to get them back on track within a few hours of Google searching, or else they'll just stop using it completely. So it's been always very important for me to provide a good error diagnostics, so that like when people send an email to us showing the stack trace, we, the developer, need to be able to figure out where things went wrong. So we've been adding a lot of hooks and so on that allows the system to diagnose itself. So that's been important for us. And also, as the Jenkins gets deployed in more and more places in multiple languages, we can't really assume that people know what Java is. Like I was looking at some of the Windows developers, and they shiver with this idea that you have to go to command prompt to type something. Right? So me being some background, it's unthinkable that you have to click the mouse to do something. But it was totally opposite in the .NET land. So we started writing Windows installers, and now I was very excited to hear about this Mac OS 10 installers and so on. So we wanted to deliver the nice native packages, like even for Unix packages, we wanted to have the right, let's say, things like log rotations and the proper demonizations, the responding with alarm, things like that. And then then finally, I myself need to push some of the features, and there are certain themes that we are I'm trying to push. So I wanted to deliver those by writing some of the plugins by myself. And so finally, so I have another, I guess, the guilty confession to make, which is about the logo of the Hudson project. So it was actually taken from Microsoft Office clipboard. And so I guess after this fiasco, someone actually read the license. I thought I read the license, but I guess I wasn't reading the part that I should be reading. And so they discovered that the clipboards aren't supposed to be used for these things. Okay, if it's probably right. And so in the Jenkins project, we have been running this new logo contest, and there was initially like 10 submissions, and we voted on those. Like we got more than 1,000 votes, I think. And then we are now down to 2, and so like we are finally doing this ultimate Robo Butler logo, the logo showdown runoff election or something like that. So these are 2 remaining icons, and then, which one looks good to you? Right one, left one? So anyway, so you can vote, and so if you can come to jenkinsci.org, and please cast your votes so that we get to see the right logo. So with that, I guess I wanted to wrap up that I think hopefully I convinced you that the Jenkins project is thriving, and both the users and developing are voting with their feet. And so in that sense, I'm quite optimistic with that. I actually think we came out stronger than before after this exercise or this divorce experience. Part of the thing that we're seeing is we got more formal and transparent governance structure that would survive long period of time. And we are working on a number of exciting initiatives like this new release models, the plugin compatibility testing, and the plugin development in other languages, and so on. So with that, I wanted to finish, but I guess we aren't really doing Q&A in this talk, but I just wanted to show we are planning like a number of upcoming meetups, so like if people are interested in talking to the developers and other users, we'll be doing another one next week, and then finally in Tokyo and Germany, Hamburg, and so on. So please come to those occasions, and we can get the conversation going. So with that, I think I'm done.
Thank you, Kosuke. Folks, this concludes our set of technical presentations. We're going to move on to Q&A. I would like to call on all of the technical presenters to come on stage. I also want to remind again, folks, if you're interested in the space of tools and automation, LinkedIn is hiring. Please send all resumes to dan@linkedin.com. Now, Yoav, Hans, Dan is right there in the back. He's hiring. For those who have questions and would like to do some Q&A, please hang around, have more pizza.
So this is probably for Hans, but certainly any of you folks, please answer. One of the things that I'm finding, I'm somewhat of a newbie to Maven, a little late, I guess, in my development, but I'm catching up. I've noticed that a lot of organizations are still using Maven, even if they're doing new development, because they feel it's the lowest common denominator. You know, so for example, if I want to develop an Atlassian Jira plugin or a Confluence plugin or anything, and I love those guys, but you know, I got to use Maven, and then I have all the problems there. How do we sort of break that vicious cycle?
Good question. So I think I don't see it really as a vicious cycle. It's something that creates stability for Maven as being an important build system. On the other hand, many enterprises have completely different pain. It's not that they can't write an Atlassian plugin. They have mission critical problems with build performance, build maintainability. So for them, it doesn't matter. So that's where we get a lot of momentum at the moment, because they really need to find urgently problems for solutions for the big problems they have. So this is all, yeah, and look at, so I think there is enough momentum behind Gradle that this is not a game changer, and slowly we will be picking up. If you look at the IDEs, what is happening. If you look, that TeamCity now has a dedicated person for doing Gradle integration into TeamCity. So we're not too worried about that. So it's not this kind of ceiling we can't penetrate. It's just there's some stuff, yes, we would like to have. I mean, I guess the same is true for Jenkins plugin development. I mean, there's a really nice way of doing that with Maven and with the whole debugging life cycle. Yes, so it would be hard to do that with Gradle. On the other hand, that's we accept that for the next 10 years, the build infrastructure will be heterogeneous. So therefore, we provide Maven import of existing Maven projects and end imports and this kind of stuff to make the threshold lower, right? So yeah, but good question.
No other brave souls?
So just some thoughts from those up there up front, and I'm looking for futuristic type stuff. So I'm sure that you guys are familiar with Jigsaw, Project Jigsaw. What I'm curious about is how do you see, so Jigsaw, for those who may not be aware, is a dependency management kind of baked into Java itself, at least class path resolution type things. And so the question is, we're ways from that. I mean, that's Java 8. Who knows when that comes out, if it comes out, I guess. How does that change the future for what we see here? Does it change anything? Is it too far off? Have you guys looked at it at all?
The Jigsaw expert has to answer that.
Not really. So, yeah, we looked at it a couple of times from the repository side of things. Last time I've heard it's going to use the resolution, which is the most interesting part for us, would be very similar to the other framework. So it's going to support Maven repositories or Maven-like repositories from what I know. That's all about it. I'm following the Jigsaw list, but seeing the involvement, it looks like it's evolving rapidly in the last couple of months. So I think we have more knowledgeable resources around here that can in the audience. Maybe they would like to comment.
I mean, I think we need definitely something much better for dependency management in the POM XML. So if you look at that, at the POM XML, it's basically a build script. You check into a repository, which you then use to actually use the published artifact. But it has the information how to compile it, which is completely different. You know, the compile class path for building an artifact is something completely different than what do I need in my compile class path when I compile against that artifact? What is the public API which I need to compile against that? And we had a long discussion about that this morning. So I think there's something fundamentally flawed with the current standard for dependency management in the Java world. And either the POM XML has to evolve to capture that, or we need something better. That's my opinion. And yeah, let's see.
One thing that is interesting for us in particular, and the information is not really available at the moment, but this dependency that Jigsaw will have, whether it will be compile time or runtime, I mean the resolution itself. So for us, if there would be hooks to actually in runtime grab dependencies, that would be also great, not just compile time. But from what I understand, it's compile time only.
No other questions? All right. Thank you, folks, for sticking around.